What we will be covering here today are the three forms of a quadratic function. The first form is going to be our factored form, or more commonly represented by y equals, here's an example, y equals x plus 1 and x times x plus 5. There's your factored form, and it will give you your roots if you solve for 0. So if we take this equation, we solve for 0, finding our roots, our factored form, we have x plus 1 times x plus 5 equals 0. Breaking that apart, we have x plus 1 equals 0 and x plus 5 equals 0. And using our one-step equations, we now can solve for 0, where we have x equals -1 and then x equals -5. So our roots are going to be -1 and 0 and -5 and 0. So now if we take this and we say that where our root is going to be, at -1 and 0 and then -5 and 0, and if we replace x with 0, which would be the equivalent of our y-axis, then our y-intercept is going to be 0, 5. So those are 3 points. Then graphing our minimum value, we would have a parabola with our roots and our y-intercept. And that is the information that you can easily derive from the factored form. Now the second form that we are going to cover is going to be our vertex form, where y equals a times x minus h squared plus k. Now your h and your k are going to be the vertex of your quadratic equation. So given our vertex form, if we have y equals x minus 2 squared plus 3, my h value, I am going to look for my h. If I replace it with our standard equation over here, my h is going to be whatever appears in the parentheses there. So my h is going to be 2. It's going to be positive 2 because the form calls for a negative in the parentheses, so you're going to have a positive opposite what's in the parentheses. Then if you notice my k over here, and then replace it, is going to be right here. So my vertex for this equation, simply pulling those numbers out, is going to be 2, 3, and of course the vertex of a parabola is either the minimum or the maximum point of that function. So let's see here for an example. So if I take my parabola, my vertex is going to be at my 2, 3 point. Now it's a positive quadratic, so it's going to be opening upwards. So you are going to have a quadratic equation which is going to have a vertex at the 2, 3 point. Now if we take another example of y equals x minus 2 squared plus 5, looking at the standard formula, looking at my offered information, I would have to assume that my vertex is going to be 2, 5, because I have a 2 where my h would be and a 5 where my k would be, and of course h and k are going to be the vertex of a function, or a quadratic function. And now given the information, if provided the value of a and the vertex of 5, 4 to create the quadratic equation, well, I'm going to do the same thing. I am going to have my function. So let's start off with, let's put in what we will never change in our vertex form, plus now filling in my h. My h is going to be my x value. So now if I just fill that in, my vertex is going to be, or my h is going to be 5. So I've got my 5. Now my k is going to be a 4, and a is going to be 1. Well, we don't have to put a 1 there to know that the parentheses are always going to be multiplied by 1, and you don't have to see it to know that it is there. So there is your, given the information creating vertex form, vertex of 5, 4 is going to give you the parentheses x minus 5 squared plus 4. Now our third form, of course, is going to be our standard form. Standard form can be written as a x squared plus bx plus c, and a, b, and c are going to be all real numbers. If we take an example of y equals x squared minus 3x minus 10, what can we get there? Well, if I look for my y-intercept real quick, at the value of my y-intercept, x is going to be equal to 0. So when x is going to be 0, if I replace it, y equals 0 minus 10, or my y-intercept is going to be negative 10. So counting by 2's, I'm going to have negative 10, and that is where my y-intercept is going to occur, and I can easily pull that from that standard form. Now I can also take that same standard form and solve for my roots. So y equals x squared minus 3x minus 10. I am looking for factors of 10. When I factor them, I am going to get a positive 3. So my larger number must be negative because my b value is going to be negative. So if I have factors of 10, I'm going to have 1, negative 10. When added together, do not equal my negative 3x. And then I have 2, negative 5. Now, when I add those together, I do get my 3x. So now I have just determined my factors of my factored form of my quadratic equation is going to be plus 2 and minus 5 equals 0. I can simplify that or solve it out. Then x minus 5 equals 0. So again, the equation is going to be x minus, or the one-step equation will work out to x equals minus 2 and x equals 5. So I have got my roots, I have got my x-intercept, and I can easily calculate my vertex. So now if I factor the information I know my y-intercept is going to be negative 10, and of course my y-axis I have numbered by 2. Just to allow it to fit. In my x-axis I have numbered by 1 increments now. Y-intercept, now my roots are going to be right here. X is negative 2, and then x is 5. I know that my line of symmetry is going to fall somewhere between those, or exactly between those. So if I see, I got 1, 2, 3, 4, 5, 6, 7. I have got 7 spaces between my negative 2 and 5. So my line of symmetry is going to fall somewhere here, which is going to be at, okay, that is going to be at x equals 1.5. So if x were to equal 1.5 and I were to substitute it into my equation, I could simply say that when x equals 1.5, what does y equal? Putting the information into the calculator real quick, I did find out that my vertex is going to be at 1.5, comma, negative 12.25. And that is going to be your vertex. And those are the three forms of a quadratic equation. Of course, all of them can be used for different purposes.